Stop. That's good.
Is that rolling?
That's good, kids.
He's like, I don't want this on.
That was Spencer that said that. Say hi, Spencer.
It was not.
Officer. Robert.
I can leave tarmac now.
All right. So guys, let's review real quick what we did last time. I'm feeling much better.
Yay!
To be completely honest, it was you ever heard of a mental health thing? I just couldn't.
Yes.
I was like, I gotta get out of here.
I have lost
Too much shit going on. I figured some of you guys probably were in the same boat.
Yeah.
Fortunately, I feel better for you, so I'm here. Sorry.
I'm always the same. It's like a day, man.
So, what we got into last time was stuff like this here. Which gotcha.
Yeah.
So how would I start? In the instructions would say simplify. So guys, can I like cancel an X out?
No.
Probably not because I
No.
didn't do it. So. But why exactly? I know I keep coming back to this, but it's about the 5th time that everybody actually hears this.
Because there's no 4.
Not because of second degree,
Because
not because there's no 4.
Because there is.
So what about here? Could I cancel an X out here?
Yes.
Totally, all day long. Why? What's the difference?
It's multiplying.
Because they both have X's.
Yeah, there's multiplication here.
You can't divide with
Or
addition.
there's subtraction. The division can't break into subtraction. It's not that strong. It's not built to do that. Division is built to be the opposite of multiplication. You can't do shit with parts of a subtraction problem. Okay. So that is the thing you guys have got to fight against. It's almost like we drilled it in your head when you see number over number to reduce it, but here you can't because it's not division of multiplication. It's division of addition and subtraction parts. It can't
So
do that.
multiplication and division are like, you can do things with them, but
Have you ever told you this?
addition and subtraction can't do things with them.
There is no division. Division is multiplying by the inverse. So division is multiplication. There's no subtraction. Subtraction is adding the additive inverse. Right? There is no spoon. So what do I do? Yeah, so if the whole thing is,
No.
birthday group, everybody. If the whole thing is I can't reduce this because there's subtraction addition, if I can rewrite these so that there is multiplication, then division is like, oh shit, I got this. So what do you do at the top? Yeah, it's one of the thank God ones, right? It's like, or think whatever your favorite deity is. What happens on the bottom?
Take out the 4.
Even better, just straight up GCF. 4 times what? And then what do you see?
Take out the X plus 7.
Yeah, the X plus 7s cancel, because division will kill the parts of multiplication. I like it.
Minus 7.
Huge alert. And again, if you make X, for example, real quick, this is the last time I'll do this for a little while. If I made X 10, and I can do that because I can let X be anything except
X plus 7.
X can't be -7 because that makes the bottom become 0, which is not allowed. So that's why I picked like 10. It's really far away from the thing it can't be. You can make X any damn thing you want it to be. But if X was 10, 100 minus 49 is 51. And 400 plus 28, 40 plus 28 is 68. Is everybody, you guys, let me just put a 10 in, right? And can you reduce these? Yes.
Yeah.
In fact, here's a really cool trick. 51 looks horrific. Looks prime. But how far apart are these? I'm sure I brought this up at least once before. These are 17 apart, so try to divide by 17. Isn't that neat? Because what's true about give me the multiples of 4. When you just start counting by 4, 4, 8, 12, 16. Aren't they all 4 apart? So give me the multiples of 17. Won't they all be 17 apart?
85.
Am I saying that if they're 17 apart, 17 will go in? I didn't ever say that. But it's a really good thing to try. Sure enough, 17 goes into 51. And 17 goes into 68. And over here, if x is 10, what is this? Right? So when we reduce it, we actually are reducing. If I put a value in for x, we're reducing what the number would be. When we do this, though, how many things did we just reduce? An infinite number of them, because x could be an infinite number of things. Here we are? Yes? Good. Okay, so that's one thing there. And I think, you gotta help me because it's been like an extra day in the middle of everything here. Did we get into stuff like this yet? What you got, Jeff? This is yummy, huh?
There's a lot going on.
Oh, dude, this is so yummy.
Debatable.
Everything's debatable.
That's debatable.
That's true. See? I was hoping somebody would say
I got you, Jeff.
So, the only difference between what I've written up here right now and what we just did is that there's more parts. There's 2 tops, 2 bottoms. So if I had a problem like this kind of problem, I do the exact same thing, but here I don't have to show myself as much because I know 5 goes into 25 5 times and 8 goes into 16. So the answer would be 2 over 5. Ooh. So over here though, I gotta write down what the shit this is because I'm not used to that. Right? So again, since there is division and in this case there's even more multiplication stuff, then I want to factor everything and just kill whatever's common, which is really what we do here. You guys, everybody with me? I'd like to make you realize how this is the same thing. This is just a little bit harder because they're not numbers. We're not used to dealing with these, but I do the exact same thing. How does this factor? You can take out a x. I'll do the bottom here. Yay, Jeff. What happens over here? You can take a 7, y, and you're left with 2y plus 10, and you could still have taken another 2 out, but actually let's just leave it the way it is, because, you see that? It's all good. And then what happens on the bottom is your favorite. I like that. When you see, what form is this? How many terms are there? 2. No GCF, it could only be squares or cubes. It's obviously cubes, right? So then you put.
So.
Yes. What's?
I said so.
Oh, so. Okay. I thought you said so, like you were gonna. So then, what do I put in the little dude?
Add.
That's a good beginning.
Minus 3.
So I use the next, use a 3. So
6 squared, 6 squared. Not,
Plus.
good. Opposite sign.
Because so.
So now you got everything multiplied out, right? I mean, everything's written as multiplication, so now division can do its job. So what dies?
The x minus 3 and the 7y.
Yeah, the x minus 3, 7 y. And then you got x times 2y plus 10 over all this business here. Blah! Chickens the ass in. So, I'm going to give you guys this here. Is it over there, Jeff? Yeah. Past Jeff left it here for you. And you're in charge of 4 people back there.
Look at that.
Holly, over there.
Look at that.
I need some new shirts. Yeah, but if I take a nap in the room, I schedule a meeting up at like 4 o'clock in the morning tomorrow.
All right, guys, take a look.
Take another nap tomorrow.
Number 2 is the kind of problem we just reviewed. Number 1, we did that kind of problem last time. Let's see if we remember. And then number 3, I'm just going to throw at you and see what you did.
Awesome.
Thanks.
Anytime.